Well, we have another question here that says question 8. Well, the question says determine f prime of x from the first principle if f of x is equal to 3x squared. Well, I'm gonna write the question over here. F of x is equal to 3x to the power of 2. Well, the first principle is given by this formula. First, the derivative f prime will be equal to the limit, okay? Abbreviate limit like that of h approaching 0 of f of x, excuse me, f of x plus h minus f of x all over h, okay? So the first thing to do here, I am going to write f of x plus h, meaning wherever I have x, I'm going to substitute by x plus h, okay? So this will be equal to 3x squared. So instead of writing x here, I'll write x plus h, and that's x plus h there. The same equation of f of x, which was 3x squared. Now we do f of x plus h equal to 3 of x plus h. Then we're going to expand this. This will be then 3. Be careful. This is not on right here. Do not do a 3x squared plus h squared. Okay, don't do that. But rather write x plus h and then x plus h. Now this will be 3 open bracket. Now we're going to do this x here times x, that makes x squared. And then x here times h, that makes xh plus xh. And then h times x, which is hx, but I prefer to write xh because multiplication is commutative. So I can write xh is same thing as hx, and then plus h times h, that makes h squared. So this will be 3x squared plus x plus h plus x plus h together makes 2xh plus h squared. Now, okay, there's a bracket here and a bracket there. Then we can just times this, and this will be 3x squared plus 6xh plus 3h squared. That's f of x plus h. Right, initially we had f of x, which was just 3x squared plus, no, only 3x squared. Then we will then write, I will now work out f of x plus h minus f of x, okay? If we do the first equation minus the second, the following equation, you can see that 3x squared minus 3x squared, they fall, and then we have left with 6xh plus 3h squared. Now, the following thing is like we're going to divide both sides by h, okay? We divide by h, we divide by h also. The idea is to get this form, okay? This whole form. Now we're doing that step by step. First of all, we work out f of x plus h. We simplify it. We got this. Now we work the numerator, f of x plus h minus f of x. We work it out over here. Then we're going to divide by h because it's divided by h here. Okay. By doing that, this will be, we notice that at the numerator here, we have like h, which is common factor. We can take h as a common factor. And now let me move my board a little bit up there. So we have left with not just, we can just take 3h. Okay, let's just take 3h as a common factor here. I just prefer to take the highest common factor. So this will be, we're left with 2x plus plus 3h. all over h. Then we can simplify. Right? We can simplify the h, and then I can move my board over here. So we have like f of x plus h minus f of x all over h equal to 3 open brackets 2x plus not 3h here but just h, okay, plus h, because we did take 3 as a common factor. Now this is the time we can introduce now the limit h approaching 0 of f of x plus h minus f of x, okay, all over h. This will be equal to still the limit h approaching 0 of, I need to move, I'll put a little bit like that, of 3 open brackets 2x plus h. Now if we work this out now, at this time when we introduce the limits, h will be substituted by 0. So this will be 3 open bracket 2x plus 0, that's the value of h now. And then this is just equal to 6x. Now if you do derivative easily, we can check that 3x squared derivative is just equal to 2 times 3 times x, 2 minus 1, and this is 6x to the power of 1, which is just 6x. Okay, this is a long time ago, before they created the rules of differentiation. People were doing this, using the limits to find the derivative. Okay, this is question 8.1. Now we're going to do the following question is 8.2. So the following question, as I said, 8.2, the question says, John determines g prime of a, derivative of a certain function g at x is equal to a, and arrives at this answer. The answer is limit of a square root of a plus h minus 2 over h approaching 0. Now they say write down the equation of g and the value of a. Well, the question sounds interesting, because the harder the question looks, the interesting it is. Okay, I think I need to read it over. It says John determines g prime of a, the derivative of a certain function g at x is equal to a, and arrives at the answer, the limit equal to, the limit of square root of 4 plus h minus 2 over h approaching 0. Write down the equation of g and the value of a. Okay, if it was university math, we would have done something called integration. Okay, it looks like this. Okay, but this is high school math, so we want to use the integration here. I am going to move my board over here and then write 8.2. So 8.2, we say that John get this answer when you work out g prime of a. Okay, you get the answer limits of h approaching 0 of square root of 4 plus h minus 2 all over h. Okay. Now, according to the definition of the limits that we quoted earlier, we did say that the limit, excuse me, the derivative first of a function, I'm just writing the formula here, f of f prime of x, okay, is given by the limit of h approaching 0 of f of x plus h minus f of x all over h. Okay, that's the limit, which is the derivative of f of x. So f of x were there, and then to find the derivative of f of x, we got this answer. Now, we have a similar case over here. So I can see that square root of 4 plus h here is my f minus f of x plus h, and then that 2 here is just my f of x. Now, how can it be? Okay, yes, it could be possible. It could be possible if this 2 was actually square root of 4. Okay, because square root of 4 is equal to 2. Okay, it's like this is like f of x, okay, plus h, and that's minus f of x. Okay, so now therefore I understand that from g prime of a is just equal to, or g prime of x first, let's work out of x, will be equal to the limit of h approaching 0, meaning that f of x was g of x was square root of x plus, that was square root of x plus h minus square root of x. It was this. Okay, the reason why a being equal to 4, you can see that a being equal to 4, that's why they substituted 4 over here, 4 over here, and 4 over there, and square root of 4 is the negative 2. Oh, so then we can say this is f of x. This is f of x. Actually, g of x in this formula, in this question. So I can say g of x will be just square root of x. Therefore, x here is just equal to x, which is a, equal to 4. You just put arrow there. Okay, if you don't get it, watch the video over again, over and over until you get it completely. Thank you. Now let's see the following question. What does it say? The following question is question 8.3. Well, question 8.3 here says determine dy dx if y equal to square root of x to the power of 3 minus 5 over x to the power of 3. Well, I'm gonna move my board over here. Split it this way, and then we have like 8.3. So it says we need to find dy dx if y equal to, as it said, the cube x square root of x cubed minus 5 over x to the power of 3. Well, it is going to be easier for us to transform the equation before solving it. Okay, sometimes functions are not presented in the way we can easily factorize. I mean, not factorize, but differentiate it. If you play soccer, okay, or like practice sports, maybe boxing, before sometimes shooting, we wait until we got the right position. So now the way the function is, it won't really help us not that much to differentiate. I know some people can still, but it's going to be easier if we transform the equation first. So x to the power of square root of x cubed can be written like this: x to the power of 3 over 2. If we use our algebra of previous grades, remember, okay, let me move this a little bit down there. I mean, I'll take this a little bit down. And then this also be down there because I want to write my formula. In the previous grades, we did learn that the nth root of a to the m is equal to a to the power of m over n. Okay, so this is how I convert this square roots here. Now, similarly, we did learn that a to the negative m is equivalent to 1 over a to the m. So remember, those formulas are useful from left to right as well as from right to left. Like in the second term here, the -5 over x to the power 3, it's going to be useful if I work it out from right to left. Excuse me. Now, over here, I can just write negative, okay? It's going to be 5x to the power of -3. So I did write it with a negative exponent. Now, this equation so far I didn't differentiate anything yet, but I just write the function in the easier way to differentiate it. So now we can work out dy dx. So dy dx will be equal to, excuse me, will be equal to, according to the derivative formula, which states that, I'm going to write the formula over here. The derivative of ax to the power of n derivative, this is equivalent to a times n times x to the power of n minus 1. Okay, so over here the derivative will be 3/2. Okay, the exponent get down first, times x to the power of 3/2 minus 1. Okay, and then minus here also. Initially we had 5, but the exponent we get down. Okay, maybe let's start with the exponent first. We have like -3 there, times 5 times x to the power of 3, -3 minus 1. So this will be 3/2, x to the power of 3/2 minus 1 is just a half, minus plus makes plus, so that makes 3 times 5 is 15, 15 x to the negative 4. Now, therefore, the derivative dy of this function, okay, this simply means we differentiate y with respect to x. That's the meaning. Differentiating y with respect to x is equal to 3/2. You can convert it to square root of x because you can rewrite it in this form, but it doesn't matter if you leave it like that. Okay, plus 15 over x to the power 4. So this is the final answer. I'm saying you can also stop here. It's not bad. Yes. The following question says, it's question 8.4. 8.4. Over here, the question says that g of x equal to -8x plus 20 is a tangent to f of x. Calculate the values of a and b. Well, excuse me. I'll move my board over here. Because of space, right here 8.4. And then we had like g of x was equal to -8x plus 20. Okay, and also we had f of x, which is given by x cubed plus ax squared plus bx minus 18. Sorry about my voice. Minus 18. Now they said g of x, this function, is tangent to this cubic function at a point x equal to x equal to 1. Now we want to find the values of a. They want us to find the value of a and the values of b. How can you do that? Now, this is possible if we know the principles, I can say the principles or rules, maybe I will say we know some theory about derivative, okay? So we do know that tangents to a curve occurs when, okay, the tangent line is simply a straight line, okay? It's a line given by y equal to mx plus c. Okay, where I call it mt to say the gradient of the tangent line. Now we also know that that gradient of the tangent line is equal to the derivative of the function. Okay, it can be even a straight line or parabola, cubic function. So the tangents to that graph will always be equal to the derivative of the function. Then, excuse me, derivative of the function at that specific point. Okay, because let me give you an idea of how this graph looks like. The graph is something like because it's a cubic function, and then the leading coefficient is positive, just one there, meaning the graph is increasing, goes up and down. So this is just a rough sketch, of the function. Okay, I'm not saying it is, but it will look like this. A tangent can be at any point. If it is here, for instance, okay, I can see it cannot be here because they said it is tangent at the point x is equal to 1. So it cannot be that place. So tangent can be this place, for instance. 1 is positive, okay, is on the right hand side of 0. So the line may be something like this, touching this point at exactly, the graph at exactly 1 point. Of course, here it's going to touch it more than 1 point. Anyway, so what we're going to do, I am going to find the gradients, okay, of this tangent, which is the derivative of the function. I'm going to do f prime of x, which is equal to 3x squared, okay, applying the derivative formulas, plus 2ax plus b, and then negative 8 derivative will be 0 because it is a constant. The derivative of a constant is 0. The derivative of a constant is always 0. Now, at this point, at the point that x equal to 1, we can I'm gonna write here. At x equal to, because at x equal to 1, okay, we will get f prime of 1, okay, will be equal to 3 x squared plus 2ax plus b. So this is just, we sub 1 there and 1 there, and then equal to, this is equal to 3 plus 2a plus b. Okay, now what is the value of 1? Okay, when x is equal to 1, y must be a certain value. Okay, what is the corresponding y value of 1? So we sub in the value of 1 in the main function of f, because this is it is tangent to this line to find the corresponding y value. So we are going to substitute. Okay, it's not available in a place here because this is the derivative of the function. We don't know what is the y value yet. Okay, I just want to call it f prime of 1. Now, what else do we know from the equation? Okay, we also know that the same tangent line, mt, it is equal to negative 8 because the tangent line is the line that is the coefficients of the x. Okay, this is the tangent line. In other words, these two must be equal because this is the derivative of f, that also the tangent, and the tangent is according to this formula. According to this formula, we say that the gradient of the tangent is equal to the derivative of the function. So over here, I will say that negative 8 is equal to 3 plus 2a plus b. Okay, I can move the 3 over, and that will be negative 8 minus 3 equal to 2a plus b. Obviously, this makes negative 11 equal to 2a plus b. Okay. Now, what else do we know from this question? Okay, we can find the value Okay, because I said the tangent is at this point, okay? We can find its y corresponding y, its corresponding y value. It will be somewhere here, okay? If I sub in the value of okay, I'm right here, f of x is something as y. So y equal to x cubed plus ax squared plus bx minus 18. So I can find also the value of the corresponding y value by substituting the value of x. If I sub in x, which is 1 there, and then y will be equal to 1 plus a plus b minus 18. So, but now this is the y value of x equal 1, okay? Because let me write here x is equal to 1. Now, it's going to be the same. It's going to be the same. What is the y value? Then it's going to be the same value at the tangent. So now, if I substitute 1 also the tangent, okay, it's going to be, because tangent means where it touches the graph. So the common points is by x is equal to 1. Now I can sub also 1 over here to find the corresponding y value over here. So I can also do x is equal to 1 using this equation g of x equal to -8 plus 20. Okay, this will be a g of 1, which is y. Okay, let me just substitute by y. Y will be equal to -8x plus 20. I sub the value of x, which is 1, and then we got like y equal to -8 plus 20, which is 12. Therefore, over here y equal to 12. Okay, because I'm going to repeat again what I said. The y value here is on the curve. Of course, it is at the same place where the tangent line touches the graph. Okay, so now if I sub in 1 on the curve, I get this equation. If I sub in 1 on the straight line, the tangent line, I get y equal to 12. So therefore, y equal to 12. Then we can say 12 here equal to, because we sub in here, 12 will be equal to 1 plus a plus b minus 18. Okay, if we move 1 minus 18 is minus 17. If I move 17 over, this will make a 12 minus 12 plus 17 equal to a plus b, and then this will be 25 equal to a plus b. All right. So now we have like 2 equations here consisting of two unknowns. So this is solvable. Okay, we have equation 1 and equation 2. Now we can solve the 2 equations simultaneously. Okay, this is -11 equal to 2a plus b. We have like -11 equal to 2a plus b, and we also have like 25 equal to a equal to a plus b. Okay, now we can, this is equation 1 and then equation 2. So if we do, for instance, equation 1 minus equation 2, okay, why I'm saying that? Well, because I can see here we have like b and b. If I minus the 2 equations, the b will be cancelled. So I can just do -11 minus 25. This will be equal to okay, I'm gonna get a larger number here. Is that correct? Let's see if I missed the sign somewhere. Did I miss anything? Let me see. Oh yes, let's double check here. This, I think it was positive. Let's see. it was a positive, let's see. Oh yeah, it was positive 18. Positive 18, I wrote negative 18 there. Okay, it was positive 18, so let's correct this. So this was a positive 18. Sometimes when we get larger number, we double check if we didn't miss anything. So it's positive 18 here. I wrote negative 18. Therefore, over here, I want to keep it in black so we can notice where we did it wrong. So positive 18. Now 1 plus 18 will be 19. Moving 19 over, it's going to be a negative 19. So let's mix negative 19. And then 12 minus 19 is equal to negative 7. Okay, now, yeah. And then over here we have like negative 7. Now, we can do, as I said earlier, equation 1 minus equation 2. So negative 11 minus 7 makes negative 11 plus 7. This is just equal to 4. Negative 4, and then 2a minus a makes a, and then b minus b false. Now we have like a equal to negative, so this simply means a equal to negative 4. Negative 4. Now we need to find the value of b. To find b, we can just substitute the value of a in either equation 1 or equation 2. I prefer to do in equation 2. So from equation 2, we have like negative 7 equal to a plus b. So if we sub in the value of a, which is negative 4, now we have like, and I can just move the negative 4 over, that becomes positive 4. And then that will be negative 3. So b equal to negative 3. So I prefer to write b equal to negative 3 like this. So here is the value of a and b. Are the values of a and b. Thank you.